For DevOps Engineer Knowledge Case 7, we're looking at general purpose code and infrastructure as code. We'll be taking a look at general purpose code with Python, Ansible, and Terraform. The first thing to understand is that we can do more or less anything with general purpose code. However, the downside of that is that we're likely to have to put in a lot more work to be able to achieve the same results. So that's what we're going to take a look at first. We're going to look at installing software with Python rather than using an infrastructure as code product, maybe like Ansible. Hello and welcome to PyCharm on my Ubuntu Linux system. And we're going to take a look at a Python script that can determine the operating system that we're running on, or release the Linux distribution, so we can use the correct packaging tool to install software. So if I navigate through to my file, so it's in my Vagrant directory, and I'm just giving it a simple name here, f1.py. Now you can see we begin by importing three modules, the subprocess, the sys, and the OS module. We then create ourselves a new function called install package, where we're taking one parameter, the name of the package that we want to install. We enter a try and except block, and in our try block we have an if statement to determine the Linux distribution that we are working with. The first check is for the file /etc/debian_version. Now, an Ubuntu Linux operating system is very much the same as a Debian, so it's said to be part of the Debian family, and it's going to have that file. If that file is present, then we're going to run our apt update and our apt install. We then check if that file doesn't exist for the etc Red Hat release, and I'll be using Rocky Linux, which is part of the Red Hat family Linux distributions. If that file does exist, then we go through and do a yum install of our package, so we can determine the packager that should be used. Now, if it turns out that neither of those files are there, then we can say that it's an unsupported Linux distribution. Moving back an indent level, then we're outside of our if block, and we run then the installation completed successfully, and we return true. We have the exception that we are managing, and it's looking for an error where it calls the subprocess .called processor error. If that occurs, we can then fail gracefully, printing out the error to the screen and then returning false from our function. Scrolling down a wee bit, we're able to see then our main block, where we look first of all at how many arguments we've supplied. And it's saying if the length of our arguments is not equal to 2. Now, the arguments include the script name. So if we've got 2 arguments, we have both the script name and a supplied argument from the command line. But if we don't, then we're going to print out a usage statement and exit out of our code. If we have provided that additional argument, then we're going to go through and set our package name variable to the argument that we have supplied. Note that it says sysargv1. argv0 is technically our first argument, and that's the script name. So our supplied argument is argv1. We then call our package installer function. So opening up my terminal, of course, I'm going to open up in my working directory the Python project, but I can change my directory to the Vagrant directory where the script exists. So cd/Vagrant, and then I can run Python 3, which is the script interpreter on Linux, and I can use f1.py. Now, if I don't provide an argument, I only have the one argument, and that's the script name. So my length of arguments is 1. It's not equal to 2. So we print out the usage statement. If we go through and check our Debian_version file, you can see that this file does exist. So if I do run the script correctly, we can see that I'll be picking up on this part of our if statement. So let's try now by providing an argument for a package that we do want to install, or at least check that it is installed. So I can go back up to my script, provide an argument. So let's try the package curl. We can see we do our update, the update of the metadata. But once our metadata is up to date, we can see then that we're able to go through and carry out the install. We're at the latest version already, so it was installed. There was nothing that we needed to do, but you can see the process has worked correctly. Okay, this is it working correctly on a Debian-based operating system such as Ubuntu. But what about a Red Hat-based system such as Rocky? Moving out to my Rocky system, we can check for the existence of the Red Hat release file in the etc directory, and we can see that we're running Rocky Linux 8.10. So this file does exist. We're not going to match on our Debian file, but we are on the Red Hat file. So if I just create a quick copy of that file and just paste in the Python code and then run out and save this. Having saved it, I can clear my screen and we're ready now to run again Python 3. The name of the script, and let's again try curl. Well, again, we can see here that the metadata didn't need to be updated, so it's only running the yum install, but it was already installed. But let's try something like the Z shell, and we can see now that we've installed the package. So we've created the one script, but it's been able to work across different Linux distributions. But it's a relatively complex script that we had to create. One of the problems addressed by infrastructure as code, such as Ansible, is that we should be able to define our infrastructure in a single language. We shouldn't have to use different terms or different programs to be able to install our software. We will be using Ansible independently on each of our hosts, both the Ubuntu host and the Rocky host. We're not going to set up Ansible in an enterprise way, but we just want to demonstrate how we can run a simple playbook to simplify management of tasks such as installing software. So come on, let's go through and take a look. Returning then back to my Ubuntu system with PyCharm open, we can take a look at what we need to do to get this working. First off, we're going to open up a playbook. Rather than having scripts in the same way that we might within our ordinary Python environment, or even our shell scripts with PowerShell or Bash, Ansible works with playbooks. If I navigate through to the playbook will be in YAML format. When I open it, we can see that it's relatively straightforward to read. We have a play, and that's called install software. These names should be descriptive. The host, we're only working with our local host. As I say, we're going to keep this simple for the purpose of the demonstration. We don't need to gather any facts about our system. We do need to elevate our privileges, so run sudo. And then we have a list of tasks. We only have one task, and that's to install the ZSH shell. And the hard work is done within the package module itself. The package module is told to install ZSH, making sure that it is present on our system. And when we're looking at this, we've got 10 lines of code compared to something like 36 lines of code we had in the underlying Python script. The reality is the complexity is still there, but it's inside of our package module, so it's kept obscured from us. Now I still have my terminal open, so using the terminal I can install Ansible. Ansible's not installed on this system. Normally I only need it installed on one system, the controller, but we're going to install it on both of our systems to keep the demonstration simple. Once it has installed, then we are ready to go. And of course, I sped up the install so we didn't have to wait to see the process of the installation, but it only takes a few minutes. We can then use the Ansible playbook command to execute our software.yaml file. So we can see we make call to the play, install software. We're running our task, and then the task has quickly finished, and we can see that there was one item that was changed. The state of ZSH was changed. If I go back and rerun the playbook, we already have ZSH installed now, so we don't need to change anything. And in terms of infrastructure as code, this is called idempotency, where the same command will give the same result. Here we're looking to ensure that the software is installed. So you can see how simple our playbook is without any conditional statements. Let's move out to our Rocky 8 system. And again, I'm going to have to go through and install Ansible. So sudo yum install -y Ansible. And we can allow the process to run through. And with Ansible installed, we have a shared file system on this machine, so we're able to access the same playbook. Remember, this is just a demonstration system. Normally we'd have communication between our machines, and we would go through and run the command from a single system against all of our hosts. You can see I'm working within my Vagrant directory, and when I list this, I've got the software YAML file, and when I go through and execute the code with Ansible-playbook, and then that same software.yaml file, my 10 lines of code compared to 36 lines of code. Now here we already have ZSH installed. We saw we installed it before. However, if I go through and remove the software, it's not going to stop Ansible putting it back on. We're looking at our required state with Ansible. So if I do a sudo and yum remove ZSH, of course we remove the product, but then go through and run my playbook again, we now need to make sure that we do have it installed so it's put back on. The simplicity of using infrastructure as code and products like Puppet or Ansible, as we've seen here, is quite clear. We take the complexity out of the code facing the DevOps person and put it towards the vendor who is producing the code. Now, whilst Ansible and other products like Puppet or Chef are infrastructure as code, because they're ensuring that your deployed infrastructure maintains its state, or newly deployed infrastructure will quickly gain the desired state. Products like Terraform, though, can deploy your systems for you. Now, this might be like Docker containers that we will look at, or it might be cloud computing in Azure or AWS. But let's take a look at Terraform. So moving back to my Ubuntu system, we can take a look at how Terraform can be used to deploy our infrastructure, not just the configuration of our infrastructure. It could be used to deploy to cloud systems such as Azure or AWS, but we can also use it locally and just with our containers. And we'll be looking at it using Docker. First up, we can take a look at the configuration file or the .tf or Terraform file. If I open up my main.tf, we can see that PyCharm is being quite decent here. It's saying it does have a plugin and I can install that plugin. It's not really going to change anything, but it will give a better visual appearance to our file. Our first block is the Terraform block, and that's really setting up drivers to be used to access, in this case, Docker. So we can see our required provider and where we get the driver from. Below that, we can then concentrate on the provider itself. And for the provider Docker, we are connecting through to the docker.sock, the socket file. Scrolling down, we're able to see that we have defined two resources. The first of these describes the image, so we're getting the Nginx and latest. Below that, we define the container that we're going to create from the image. And notice that we reference the image within the container. We set up the name for the container and set up our port mapping. Port 8080 on our host is going to be mapped through to port 80 in the container. The nice thing about using Terraform is that it can create and destroy our resources, so it leaves the system back in a tidy state once it has finished. Now let's get some typing fingers on because we have some administrative work to take care of. Let me open up the window a little bit, and I'm going to gain full administrative rights with a sudo -i, so I've got an interactive shell. The reason I'm doing this is obviously I have to install software such as docker.io with administrative privileges, but also to run Docker, once it is installed, I must be a member of the Docker group or root. So to save messing around, I'm just going to run as root. Now that it is installed, I can go through and check something simple, the Docker version. And when we take a look at this, we can see then that we've got both the client and server versions showing. When I look at Docker images, obviously I'm not going to have anything installed, but you'll see once I run the Terraform file, we'll have the image installed, but it will also then be removed once we destroy the resources. Talking of Terraform, it's not available in our apt repository, but it is in our snap repositories, so I can do a snap install Terraform --classic, and then it's just Terraform space version to check the version of Terraform. It's saying it's out of date, but it'll be good enough for the demonstration purposes. I'm going to create myself a directory to work in, so I'm going to just call it Terraform, but you might have different projects below that. I can copy from the Vagrant directory the main.tf that we were looking for, and I can copy it across to my current directory. And of course, when I list it here, it's going to be in my home directory, so ls. Of course, I need it in my Terraform directory to organize my resources that we are creating. So I'm going to copy the main TF through to Terraform and move into the Terraform directory. And then from here, when we list it, we've got the main TF. The first thing that we do is make sure that we've got the driver for the provider provided. So if I now do a Terraform init, we look for the driver online, we download it, and it's installed into this directory. I can now do a Terraform validate to check the main.tf is correct, and then we run our Terraform apply. So this is then looking at what it needs to do. I have to accept that I want these resources created, so I can enter yes. I can automate this if I want with a --auto-approve option. So it's downloading the image, it's creating the container, and now I can go through and look at my Docker images, and the Nginx image is downloaded. Docker PS will show me my running container. So everything is up and running, and let's check the port mapping, going to localhost and then 8080, and we can see the default Nginx web page. So everything was created as we defined within our main TF. But I could also go through and destroy everything with Docker destroy. Again, I have to accept the prompt, but I could automate it. But now everything that was set up has been removed. When I look at my Docker images, there are no images. And when I look at the Docker PS-A, I'm not seeing even the stopped containers. So the container was deleted, the image was deleted. So we've tidied up after ourselves, and we have a clean system, which is always good when you're working with many different containers. So summarizing a little bit about Terraform, using Terraform, we have .tf files. The TF file will describe the provider that we are using. It will describe resources that we are creating, and those resources might be many, but those many resources might be linked, such as we saw with the image being linked into the container that was being created. With Terraform installed, we can use Terraform init to download the drivers. We can use Terraform Validate to check the syntax of our HCL.tf file. And we can use Terraform Apply to make our changes, and Terraform Destroy to, would you believe it, destroy our configuration. So look at yourself. You are now fully versed in general purpose programming. We've seen that we can use Python to do a lot of the work for us. So if we have different Linux distributions that we need to install software on, we could use Python. But we saw then that it was 36 lines of code. With a little bit more efficiency, we could look at using Ansible. Ansible is a free product, and we could see with 10 lines in our YAML file, we were able to do the same and have very readable and maintainable file. But Ansible is infrastructure as code, but it's not just about managing your infrastructure. It's about deploying your infrastructure as well. And we saw that using Terraform, we could deploy Docker containers with the configuration that we required.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.